Okay. Here we go.
Oh my god, X is so hard to find.
I know, it's great. So, when I say solve this equation, what do I mean?
Put 2 there. Find it.
Put 2 there. That's what you mean.
Sure, 5 minus 3, put a 2 there, but that's not actually the answer I'm looking for.
Solve for X.
We want to solve for x. So I want to find what value for x is there. So in this case, it's obviously 2 plus 3, which is 5. Easy enough, right? So when I say solve this equation, or solve any equation, I'm just looking for you to give me an answer to the variable. Now, when I say solve this equation, what do I mean?
You solve for y/x.
Okay, a little more than that. So we are solving for y and x, but what is it that I need?
Give you the answer.
Because, for example, if, let's say y was 5, then what would I do?
You would do 5 minus 1 to solve for x.
Which is,
4.
okay, but what if y was 10?
And you do 10 minus 1 to solve for x, which is 9.
So what I'm trying to find are values for x and y that are or make this equation true, right? So I need values for x and y to make that equation true. But that's the point, is there are so many different ones. And in fact, in this case, there's an unlimited number of answers. This could be 1 and 0, right? We could have 1, 0. We could have 2, 1, 3, 2, right? There's an unlimited number of answers for this. So, how many solutions are there? Infinity.
Why don't you write the infinity sign?
Infinite. Because I like writing words. It's good practice for me since I can't spell. And what do the solutions look like? So when I have a solution to this, so let's say it was 2 and 1, right? So y is 2, x is 1. What does the solution look like? How do I write it? Any ideas?
Y equals that and x equals that.
Well, we can start with that. So y equals 2, x equals 1. But the way that we want to write
Plug it in.
No.
Oh.
The way that we write this is we call it an ordered pair. So we write it like this. Your x value first, y value second.
Yeah. Oh, do we get to grab that thing?
X, yes. X comma y, right? So that's how we do that. That's what solutions to this look like.
Ooh, let me get the graphic
So
thing.
first I'm going to fix my board.
And we need graphing paper.
And you need graphing paper,
Which you can get us. Mr. Nastaway said.
which is over there. So no, I'm not going to get it for you. There it is. Huh?
You broke it.
I think I did break it. And the best part about this is going to end up
breaking?
What is this gonna end up?
in the thing.
What?
There, it showed up. For some reason, the middle one didn't show up, and then it screwed up.
What's that thing on the...
No idea. Just leave it there. So, we need to draw a line and a graph from an equation. Okay? So, the graph paper's over there if you need it.
We did this in like 7th grade.
Yeah. But I need to introduce it this way, something you remember doing, before I get into something new that you haven't done. I don't know, there's a whole bunch over there. Well, some of them are kind of messed up. You're right, some of them are messed up. But, you know, it does the job. I'll just have to print off more later.
What are you trying to find?
Normal graph paper.
There's none.
There's no normal graph paper.
Well, go with it. I'll have to print off more later.
How do you do it with this?
No.
Okay.
Draw across.
So here's our equation. Y equals 4x minus 2. So if I want to graph this equation, there are several different ways that we can do it. But the way I'm going to start with now is with a table of values. Because later on, maybe not this year if we get to it, but next year, we're going to use the table of values to do transformations and things like that. So, we make a table and fill in some x and y values. Start by picking any x that you want and using your equation to find y. Now, in this case, I picked values for x, 0 and 1. Okay? But you can pick any values you want, anything at all. Mind you, you don't want to pick 874 because that might not fit on your graph. But you can pick any values that you want. So if here I have x is equal to 0, that's not going to leave. Okay, so we have x is 0, so I just plug it into my equation for x. So if x is 0 here, 4 times 0 is 0, minus 2 is negative 2. So my y value is minus 2. Right? Then I put in 1 in here, I get 4 minus 2, which is positive 2.
How
Exactly.
we found x?
How we found y
Oh,
is we did
we
that
do that?
calculation. No, you don't have to add that in, but you should show your calculation anyway. Sometimes it's easy. I mean, if y equals 2x, I don't expect you to show me 2 times whatever you pick because that's an easy calculation. But if the equations get more complicated, you throw in fractions, things like that, then you should show your work. Just
Is
so you
y
know.
up or across?
Vertical, so up, and horizontal is x. So the point that we get, 0 minus 2 and 1, 2.
So you have to choose 2 numbers. And then
Say that again?
So you have to choose 2 numbers that you use as x.
Yep.
And then you do the points on their places in them.
Yes.
Yeah, and then you do that again and go up and...
Well, you don't have to. Once you have 2 points, that's all you really need. Because you can
But
just
sometimes you have to make the line go, make a straight line through the points.
Okay. So, once we have our points, we can plot them on our graph. So I have it done here. I know it's hard to see, but this is 0, 2. This is 1, 2. Okay. I just put those 2 points and then I draw a line through them. You don't want to just connect the dots. You want to make sure that your line goes all the way through and keeps going, right? Because these linear equations, they go on forever. They don't stop. So you just draw a line all the way through, okay? So I put my points, remembering this is x, this is y,
Wait, what am I doing?
and then we connect them with a straight line. Easy enough, right?
Yeah.
Yeah. Okay, well then, let's try an example.
Do we plot
Or rather, 3 examples.
Do we plot the banks?
Before, it appears as if you have no idea what's going on. So, I will do the first one for you. Equation number 1.
Okay.
X, y. So you make a table of values here. You pick 2 numbers for x. Any 2 you want. So I'm going to pick 0 and 1. Okay. So, when x is 0, I have 2 times 0, which is 0, minus 3, which is negative 3. When x is 1, I have 2 times 1, which is 2, minus 3, which is negative 1. So, these are the points that you get. So the point for this one is 0 minus 3. That is 1
So
point.
you count the numbers.
X value, y value.
Yeah, I get that.
Your second
I
point
did that.
is 1 minus 1. Okay? X value, y value. So when you go to your graph over here, this is x,
Oh, I get it.
and this is y. So when x is 0, y is minus 3. So I get,
I get it. I
so
see
I get a point here. When x is 1, y is negative 1. So I get a point there. Right? The x value goes here, the y value goes here, and then you plot your point.
Yeah, I get it.
And then once you have this, you just connect the dots. Mind you, you should use a ruler for this, but you know, I did my best.
I also go.
Also, you
Yay, this is
Okay. Sure. Give it a shot. So, I'm going to do the third one first, and then I'll talk about the second one. So the third one, several people made the same mistake.
Like 4
Okay, so I'm going to pick values for x. I'm going to pick 1 and 2. This is where writing it in a table helps, because the people that made this mistake did not do this, which is part of the reason why you got confused.
I kind of did. I did it on the back, but not on the table.
Okay, but The people that made the mistake, like I was saying, which you did not, did not do this, and that's why you got confused. So, the value I picked here for x is 1, okay? So, I put it into my equation, and for this one I'm going to write it out. We have negative 1 plus 6, right? Because I picked 1 for x, I just changed x to 1. But in my equation, it's negative 1. So when I solve this, it's minus 1 plus 6, which is 5. So my value for y is 5. But the value I picked for x is still 1. That doesn't change. Right? This is still going to be 1, not negative 1.
Okay.
Because the equation does not pick the values that you chose in the beginning. Okay? So then I pick x equals 2. So I change this to 2 now. So minus 2 plus 6 is 4. So my y value is 4. So my point is 1, 5. 1 for x, 5 for y. And my point here is 2, 4. 2 for x, 4 for y.
Mr. Heath, and if you go x3, it would be 3, 3, 3.
Yeah, 3, 3.
It goes like,
And then it will be 4, 2, and then it will be 5, 1, and then it will be 6, 0. Yes. There's a pattern, which is why we call these linear, because of that, for that reason. So now I'm going to put my point. So when x is 1, y is 5. That's about here.
Or is it?
And when x is 2, y is 4, which is about here. So our line looks like that.
Okay.
And this would be our line y equals minus x plus 6.
And do we have like where the two, do we like draw something where those two intersect?
Well, we'll get to that later, but yes. We do talk about that. Solving a system of equations is where they intersect. Yeah. So the last one here, number 7. Y equals 7, sorry. But, yeah. This one is interesting. So again, for the same question, I'm going to make a table. Oh, well, that was convenient, but not what I wanted.
But what?
Okay, so x and y.
But there's no x.
So, when x is 0, what is y?
0, 7.
When x is 1, what is y?
7.
When x is 836, what is y?
7.
So y never changes. Y is always going to be 7,
But
no
why?
matter what value you pick for x.
Why does
So-
y never change?
If this is 1, 2, 3, 4, 5, 6, I guess 7 would be up here, then y is just a straight line across. Y equals 7.
But that's gonna just make it weird.
no,
Yeah, because you'll have
it's
an extra line on
math.
the
You
cross.
can't judge, man.
So you'll just have it, if there's more, you'll just have more lines.
Well, normally your lines are different, so you can tell. Plus your axes are labeled. So you'll label this line as y equals 7, so you'll know that it's a line.
Yeah, don't you write like at the line the formula thing, in brackets 1 thingy?
Is this some kind of science model here?
That belongs to Martin, and he just feels like leaving it there. I told him one day it'll disappear.
Yeah, but it's like right above the
Yeah, he did that on purpose.
What? What did he do?
And why did you open it? Water?
So, do you understand why this is the way it is?
Yeah.
Basically, no matter what it is, if I said y is negative 1, it's just a line straight through y equals negative 1. If I said y was negative 5, it's just a straight line through y equals negative 5. Because what it means is no matter what value for x, since there is no x, y will always be equal to 7. So I just, draw it across. So I can pick anything for x, it doesn't matter, because y does not depend on x. So y is always going to be 7.
And if we had it with x, then we'd have it like,
And the same thing would go for x. If my equation was, say, x equals 7, then I would just have a vertical line going through x equals 7. Because y will never change, or no matter what y is, x will never change. Y can be anything, but x will always be 7. So it's just a vertical line.
okay.
Are there any questions about this?
No.
Okay? So what you will do, grab yourself a textbook and open up to page 184.
Can you take one for me?
There's only 2 more left, so fight begins. The hungry.
Yeah, or the fight begins.